In this FreeCAD tutorial, we'll explore how to create a fully parametric multi-pitch threaded rod using joined helices in a change-safe way that avoids the topological naming problem. The idea originated from creating lead-ins and lead-outs by selecting the final face of one helix and extending it with a second helix of the same pitch. The thread can then be blended into the body by adjusting the height and cone angle. But this approach is not stable. If the thread is later extended and the seam moves beyond the helix end, a new face is created. This breaks references and requires manual reassignment of supported geometry. A more robust solution combines the mathematics with a SubShapeBinder. This approach is inspired by a method developed by a Patreon supporter who linked datum plane angles and profile positioning to attach an end profile to a helix. Here, similar principles are used but implemented through a SubShapeBinder. Together, these methods produce a change-safe helix with tapered ends, eliminating these issues, making them suitable for advanced designs such as threaded rods with variable pitches. Let's explore this issue and the solution by creating a parametric project for a multi-pitch threaded rod. To make a simple threaded rod, we'll start in the part design and create a new body and a new sketch on the XY plane. Using a simple circle constrained coincident to the sketch origin of 10mm in diameter. So we hit close, and then we use the sketch and pad this by 50mm. We have a simple rod that we'll add a thread to. Next, we'll create the profile for the thread. I want this on the side plane, the XZ plane. Now it doesn't matter which side we actually create the profile on. If we use the toggle section view, we can see through this. I'm going to attach to the edge here, the seam edge, and this is the edge that causes the problem. I'll just flip this around the other side by clicking on the sketch and coming down to the map reverse and just setting that to yes, and then using the view sketch. So now we've got this to the left. It's just my preference. You can do it to the right if you want. We'll change the geometry to construction geometry. Now I have something selected, so make sure we have nothing selected and then change it. So these are all in blue. We'll use the external projection tool and pull in the edge. So this is coming in as construction geometry. It's dashed. Make sure we cancel the tool by right clicking and changing these back to defining geometry. I'm just going to sketch a really simple profile. That's just going to be a triangle. And we'll create a triangle and place it to the left. So right click to cancel the tool, taking the two endpoints, selecting them both, and the imported edge. We'll make those point on object constraint using the combined coincident and point on object constraint, and set a distance from these 2 points around of 2mm away from the bottom. Let's also dimension this construction circle as well. Let's say 2.5mm. So we have a basic profile. Let's close, and now we can apply the helix. Bring this around this way so we can see what we're doing, and zoom in. So at the moment, the sketch, the profile is selected, and we select the additive helix. I'm going to change the pitch of the helix to 5mm, and we'll set the height to around about 40mm, taking up most of the body of the cylinder, and we'll hit OK. So this is where the problem occurs. If we want to add, say, a taper from this face, then we could select the face and then create another helix from there. Setting the same axis, base Z, changing the pitch to be the same, 5mm in there, same pitch, and a shorter height of 1.5mm. So across in this seam here, the cone angle will change just to push this back into the body to make the taper to minus 60 degrees. We can adjust this to get a better fit. So that's our taper. If we OK that, we can see what's happened, but this won't survive a change. If we look back and hide this helix and just show the previous operation, we can see the face that we created a helix from. Now, if we change this helix and reduce the height, so we've moved away from that seam line and hit an OK, we see that it hasn't changed, but we have a null shape here. An error has occurred. If I click on that helix and look down, we can see we have a profile here. And it's saying helix face 29. Let's just cancel that and show the previous helix. This face here, we look down to the bottom left, we can see that's saying face 27. Let's set this back to 40 millimeters. Our helix is no longer in error. We see the face is 29. We look down to the bottom, and the same if we extend past. So let's set this to 41. Again, we get the error. This time we have face 30. So the face is changing as we pass that seam line. To fix this problem, let's delete the additive helix. So now we have a stable model. We're going to use a SubShapeBinder. So if we look down to our original sketch, which is sitting here, open up the additive helix and show the sketch. We can see the sketch sits there. So you can see it highlighted there. If I take that sketch and create a SubShapeBinder, we can use this binder as a profile. We just need to set the offsets to position it at the right position. So if we mathematically link this to the helix, we should be able to position it correctly. So we take the binder, it has a placement. The first thing we're going to change is the angle. We use the expression editor on the end. This will link the value to the properties. So we need the additive helix and its height. So additive helix.height, divide that by the pitch, then times that by 360 degrees, and OK that. If we click off, this is the correct angle, but we need to change the position. So if I look up, we can see that SubShapeBinder is now in the correct angle to connect to the end. So the position on the binder, if we look down and look at the Z position, again, we link this, and this is just linked to the additive helix dot height, and hit OK. The SubShapeBinder is here. If we click off, it refreshes, and we can see it's moved into the correct position. So now the binder's in position. Let's create the additive helix, making sure we use the base Z. The pitch we can link back to the additive helix, the very first one, and we'll set that to the pitch. That links them. The height, we'll set this to 1.5, and the cone angle, we'll set this one to minus 60 as before. We get a nice taper. Hit OK, and now this should be stable. So if I change the original helix, and we'll just move this down, say, to about here, we get no errors. And let's change this and move this up. And it's nice and stable. Because we've used an additional helix and it's safe, this means that I can change this to have a multiple pitch thread. So we can daisy chain the helix onto another one. Let's do that. So let's change the cone angle and zero that out. Remove the pitch, reset that. I set the height something like 6 and change the pitch, reducing it to say 3. So we've got a different pitch here. Now I want to add, say, another helix onto the end of this one. This is where we take, rather than the sketch from the original helix, we take the binder. The reason being, is that it's at the position, and we can't really see it there. Let's hide this one. So it's at this position of where we started the upper helix. So we just need to offset from this position to this one here. If we took the original sketch, then we would have to add the height and the second height, and also with the angle, we would have to add those two angles together. This saves you that bother. So let's take the binder and then create a subshape binder of that binder. This time we take the binder, position along the Z is going to be the additive helix, the second one, 001.height, and the angle, we change that to the additive helix 001.height, and then divide that by the additive helix 001.pitch, and then times that by 360. Let's click off, and we should see the binder, and we can see it there. It's positioned on the end. So we can take the binder and create another helix with something different. So all of these now should be changed safe. So let's go to the original, and we'll pull this down this way. The next one, we'll push it forward, and everything, as you can see, is nice and stable. If we wanted to, we can add a var set and attach these to the var set, so changing the pitches and the height of each of these sections, or we can do that with a spreadsheet as well. So that uses the ShapeBinder method. In another tutorial, I'll go through the data method that's more in line with the original Patreon solution and show how that can be used to position and create different profiles along that helical operation. Hope you enjoyed that video, and I hope to see you in the next one. If you like what you see and you want to donate to the channel, then you can do so via Ko-Fi or Ko-Fi at ko-fi.com/MANG0, or via PayPal at paypal.com/paypalme/DarrenBEstone. I also run a Patreon where you can get early access and additional content, and that's at patreon.com/MangoJellySolutions. Links can be found in the channel header, on the About page, or in the descriptions of these videos. I thank everybody that's donated so far. It really helps to keep the lights on so I can produce more content and also expand the channel. Thank you for liking, commenting and subscribing to these videos, and I hope to see you again in the next one.